get through these notes pretty quick. Okay, so if everybody will look at page 19 in their journal. We've already filled out one blank. We said that direct variation is also known as a proportional relationship. Okay, so we're going to be looking for proportions. We're going to specifically talk about what the graphs of a direct variation look like. We're going to also look at the patterns that direct variation fall into. So let's talk about direct variation with a table. Okay, that's whenever we have our x's and our y's, obviously in tables. Where's our x in the table? On top or where? Think about a table. It could be on the left or on top. So what does that mean my y is? Right or the bottom. Okay, so let's talk about direct variation between two quantities. So quantities is a fancy word for anything. So the direct variation between two things is a relationship in which the ratio, what does ratio mean? You're dividing. It's literally a fraction of some sort, in which the ratio of one quantity to the other quantity is constant. So the other day we talked about direct variation also meaning a different word. What do y'all remember? What else does direct variation mean? Slope. Okay, so what is slope? Use your words. What is slope? The rate of change, but more specifically the constant rate of change. So when we're talking about variation, we're still looking for a constant change, a constant proportion. Okay, one quantity to the other quantity, we're going to compare our x to our y in tables, because those are the only quantities they give us, x to y's. Now let's go look. It says determine whether each of the tables below represents a direct variation or not. Okay, the only way we can do that, and the only way we can prove this, is if we figure out the proportion. What are the two things we're going to compare? X and y. But what do we always put on top when we're talking about slope? Our y's. So we're going to put all of our y's on top of our x's. So what's my first y? Over. Perfect. Then 12 over 2. Then what? 18 over 3. Then what? 24 over 4. And? Okay. Now remember, just like this proportion problem from here, we had to go see 14 divided by 2 was 7. And 126 divided by 18 was? That's the only way we could tell that they were constant. It was a proportion. So here, instead of doing cross multiplication and having to do cross multiplication 17,000 times, really only 5, but that's a lot. Okay, we're going to use our calculator. So everybody's going to grab your calculator. We're going to go to our normal screen. And what is a proportion? It's just a what problem? A fraction, a division problem. So what was my first y? Divided by? 1. Press enter. Don't clear it out. Do not clear it out. Okay? Y'all have a habit of clearing out after every single thing you type. Don't clear it out. We need to compare all of these. So what's my next one? 12 divided by 2. So far, is it constant? Yep. Okay, what's next? 18 divided by 3. Divided by 3. Wow. Oh, wait. Coach Williams typed in the wrong number. Okay, is it constant still? Yes. Next? 24 divided by 6. Or is it 4? 24 divided by 4, and then? 36 divided by 6. So, when you compare their proportion, y over x, was it constant? Yes. What was my constant rate of change? 6. So, yes, this one is a direct variation, and my constant rate of change was 6. Let's go do the next table. What am I comparing? X and y, but what do we always put on top? Y over x's. Okay, so I've got 14 over, good, and then 7 over, then negative 7 over, then negative 14 over, and negative 21 over 6. Okay, y'all start doing it in your calculator. Let's check to see if they're constant or not. We've got, I'm going to clear out now because this is a new problem. 14 divided by negative 4. 7 divided by negative 2. Negative 7 divided by 2. What else?
Negative 14 divided by 4.
Perfect. And last one.
Negative 21 divided by 6.
Negative 21 divided by 6. Were they all constant?
Yes.
Yes? And what were they constant at?
Negative 3.5.
Perfect. So we're going to say direct variation. It was constant at negative 3.5. Are we okay with this? Okay, let's look at C. Let's see if this one's constant. What are we going to compare? X and Y's, but we're always going to put our Y on top of our X. Okay? Does anybody need these notes? I didn't even ask. There you go. I apologize. So that's all right there. And we can get you caught up. Okay? So, what am I putting on top of each other? So 6 on top of? 6 on top of?
8.
Good. Then what?
Negative 12 over 4.
Over what? Negative 4. There you go. Then what?
0.5 over 96.
Perfect. Then what?
120 over 0.4.
Then what?
40 over 0.8.
Okay, so always our Y's on top of our X's. Now, we're just going to go in our calculator. We're going to clear out what we have. What was my first Y? 6 divided by 8. Okay, next one.
Negative 12 divided by negative 4.
What do you automatically notice? They're not the same. So guess where I get to stop? Right there, because this is not equal. Therefore, this is not direct variation. Are we okay with that? If it's not constant, it's not direct variation. So let's look at the last table. You do this one. I'm going to race you. Ready, set, go. Oops. Is this constant? Yes. So is it direct variation?
Yes.
Yes. We're going to put direct variation, and what was its constant of variation?
0.0625.
0.0625. How do y'all feel about finding direct variation from a table?
Good.
Pretty easy. We just compare our Y's over our X's. We make sure that they all give us the same constant change. Okay? Now let's go look at direct variation inside an equation. Okay? So go to this front flat. What does this equation look like to you? Should look kind of familiar. It does say y equals kx, but what does that look familiar to? Slope. Tell me that equation that deals with slope.
Y equals
mx plus b. Okay, so what looks familiar? This part, the k and the m, right? So what do you think k is standing for? The slope. Okay, again, direct variation is kind of very comparable to slope, so it would make sense that they're very comparable equations. The only difference is what? It has a plus b on y equals mx, right? Does it have a plus b down here? No. What does that mean? What? Say it with confidence. It's going to go through the origin. There is no B. If there's no B, what do you put there? 0. Okay? So it's like saying plus 0 at the end. Because there's nothing there. Okay? Now, if you have a plus 0 as your y-intercept, the only way to put that is to put it at the origin. So every single graph you see that goes through the origin is always considered a direct variation. Any graph that goes through the origin, it's considered a direct variation. If it doesn't go through the origin, guess what it's not? It's not direct variation. Pretty simple? Okay, let's go look at equations. A direct variation can be written as an equation in the form y equals kx. We're going to change that letter a little bit because direct variation is a little different than slope. Okay? Where k represents the constant of, not change, but it's close, variation. Because remember, we're talking about direct variations. So we're going to have a constant of variation. Are we okay with that? And really, guys, you're right. It's very similar to finding the slope. Are we okay with that?
Mm-hmm.
So let's go look at these equations. Let's see if they fit direct variations. First equation is y equals 6x. So let's go write y equals kx underneath. Does this match that format?
Yes.
Yes, so guess what? This is direct variation. And what does my k equal?
6.
Oh my gosh. Y'all are brilliant. Okay, it's really this easy. Don't overthink it. Next problem. If we go y equals kx, does it fit that format? No, because it has what? It's got some extra. So guess what? This is not direct variation. It's really that simple. If it's got extra at the end and it's not a 0, like if they wrote plus 0, wouldn't that be the same thing as not having a 0 there? Okay, but if there's some other number there, it's not direct variation. We okay? Look at this problem. Y equals kx. Is this direct variation? Good. What is my constant?
1/2.
Y'all are so smart. Okay, next problem. Do we have y by itself yet? No, so what do I need to do to get it there? Divide by 3. Because remember, 3 and y are stuck together. The only way to get things stuck together apart is to divide them. Okay? So y equals what? 3x. Now, does that fit y equals kx format? Yes, so what is it? It's direct variation. My k equals, y'all are brilliant. Next problem is y by itself. What do I have to do? Divide by 5 on both sides. So y equals, what's the understood number in front of my x? 1. So what's my slope? 1/5. Don't forget you were dividing. So this is a direct variation, and my constant is what? 1/5. Is everybody okay with what I'm doing so far? Not hard? Okay, last two problems. Are these in the format I need them to be?
No.
No. So what do I need to do? Solve it. Am I solving for x or am I solving for y? Y. Go circle your y. We've got to get that y all by itself. Is there any distributing? Any combining? Any moving? No, because my y's already where? By itself on the left. Okay, I need to add or subtract the extra stuff. What would be considered extra stuff up there? What's being added or subtracted?
15.
That 15 what? 15x. I've got to get rid of the extra. Okay? So get rid of your x's. How do you get rid of a negative 15x?
Plus 15x.
Whatever you do to one side, you're going to do to the perfect. I'm going to be left with 5y equals what? 15x. I'm going to write plus 0 out here. Why did I not combine those? One has an x, one doesn't, right? I know it's 0. Y'all are like, Coach Williams, you don't need to write a 0, but I want to show you something, okay? Is everybody okay with what I'm doing? Now, what do I need to do? Divide by 5. Again, 0 doesn't matter, so now you can cross it out. Does everybody understand why that's okay? Okay? So, what is 15 divided by 5?
3.
So, y equals 3x. Is this direct variation? Okay, so yes, it's direct variation. What's my constant of variation? 3. Let's go look at this last problem. We are going to obviously get my y by itself. Is there anything adding or subtracting that needs to be moved?
6.
How?
-6.
Minus 6 to both sides. So I'm left with 3y equals what? 9x minus 6. Good job. So I did that 0 earlier, so you would recognize you can't combine these things, right? Here, can I combine a 9x and a 6?
No.
No, one has an x, one does not. You can't combine them, so you write them side by side. Sound good? Now, what do I do? Divide by 3. This should look familiar from like the very first week of school. Don't break my heart. What's 9 divided by 3?
3.
So 3x. What's negative 6 divided by 3? Say with confidence. Negative 2. Okay? Remember, we're dividing, not subtracting. So, does this fit my direct variation format?
No.
Y equals kx?
No.
Why does it not fit?
It has extra.
We've got extra, so this is not direct variation. Are we okay with that? Okay, now let's do this quickly. We're nearly done. Ready? We've already talked about graphs of direct variations. We've talked about graphs. Where do they go through? The origin. If they don't go through the origin, are they direct variation? No. So the graph of a direct variation is always a straight line that goes through the origin. What ordered pair is the origin? Say with confidence. 0, 0. Okay? So it tells us to graph each direct variation equation. Well, where do we know they all start? So go put a dot at the origin. I'm going to change my dots to blue. Okay? Now, what other information did they provide me with this equation so that I could graph this problem? Did they give me anything? They gave me slope. What is slope? Rise over run. It's the rate of change. So what's my rise over run from this problem? So, from the origin, how far up do I need to go? Up 3, then where? Which way? Right 1. I've got to create a positive line because it was a positive 3. Now, the cool thing about graphing, guys, is if you know your rate of change, you know your slope, you do it once. We need 3 dots on our graph, though. So, if I do it up 3 over 1, can I go up 3 over 1 again?
No.
No. But what could I do to get here? Down 3. So I can do the complete opposite to get my other point. So from the origin, if I go down 3, left 1, did I still follow the same pattern?
Yes.
Yes, because when I connect the dots, it's a straight line through the origin. And if you go look, this is very simple to check. Always check yourself. You start at this point, up 3 over 1. Up 3 over 1. Did I still land on this same line?
Yes.
Okay? Just because I went opposite doesn't mean it changed anything. My rate of change stayed the same. Got it? Okay, so positive line, perfect through the origin. Let's look at B. Where do I start?
Origin.
Origin. Now what's my rise over run? I've got down 1 over where?
2.
Down 1, which way? Right 2. Okay? Could I go down 1, right 2 again?
No.
Yes.
I could if I wanted to. It's right there. But what's the opposite of down 1? Up 1. What's the opposite of right 2?
Left 2.
Left 2. So notice, when I connect these dots, they're all on the same line. They all have the same rate of change. It's constant. Are we okay with this? Do you see the difference between a positive and a negative line? Okay. What's wrong about C? Say with confidence.
It's not in y equals kx.
Yeah, it's not in y equals kx form. So what do I need to do? Say with confidence, Emma. Divide. So I've got y equals what?
Y equals 2/3 x.
Y equals 2/3 x. Is that now kx format?
Yes.
So where can I start my graph? At the origin. What's my rise over run? 2 over 3. So where do I go? Up 2, right 3. Can I go up 2, right 3 again? No, I'll be off the graph. So instead of going up 2, right 3 from the origin, where should I go? Down 2, left 3. And when I connect these dots, make sure you always end in arrows because your rate of change is constant and it keeps going. Are we okay with this?
Yes.
Okay? Look at D. Is it ready to be graphed? No? What do I need to do? Divide by -4. Y will equal, what's that understood number in front of x? 1. So now y is going to equal 1 over -4x. Do I know my rise over run? Yes. So where do I start? Origin. It's direct variation. There's no b on the outside. So now where do I go? Up 1. Left 4. Can I go up 1, left 4 again?
No.
So let's go do the opposite. Instead of going up 1 from the origin, where am I going to go? Down 1 and then where?
Right 4.
Right 4. When I connect these dots, it should create a what type of line? Straight line that's going through the, and it's also negative because my slope was negative. Let's see how smart you are. It says to write an equation for direct variation. So what should the direct variation equation look like?
Y equals
Y equals what?
kx.
Kx. So where do we know it goes through? The origin. Then what do I need to find? Right. Well, I know my y and my x stay the same. What's the only thing I need to find? My k, which is my slope. I'm going to look for rise over run. How far up do I go from the origin?
5.
So up 5, and then how far do I run?
2.
So y will equal what? Y'all are so smart. You got it? Not hard? Pretty easy? Okay, so here's what you're going to do. Ready? I've got to explain a few things to you before